everyone, we are students at Hawai'i Preparatory Academy, and we are right now conducting a research project using the emotive headset, which we first saw on a TED Talk presented by Tan Lei. I'm Rico, this is Duncan,
Hey.
and Fong is our cameraman. Hi Fong. So what we have is the software development kit and the research kit for the emotive headset. So up on the big screen is an EEG, and that is measuring the electrical activity of the neurons in Duncan's brain. And we also have what's called an FFT, and that is showing us the different amounts of brain wave frequency that are going through his head right now. So they're classified into 4 different categories: delta, theta, alpha, beta. And the higher the frequency, high frequency waves are classified as beta waves, and then it goes down, the lowest frequency waves are delta waves. Down here we have a 3D brain activity map, which will actually show us what part of Duncan's brain is in use right now, as well as the 4 different wave classifications again. To the left we have, this is the software developer's kit. What's really cool is we have a cube that stays in space, and you can train the cube to do something. For example, we train it in neutral mode and the cube doesn't move. When Duncan thinks about something, he's programmed a thought to, for example, right now push the cube, and that thought allows him to push the cube. You can train different thoughts to do different cube actions. Sometimes it spins. Right now he's pushing it forward, and that's completely done with his brainwaves. Now he's spinning the cube, all with his head. So what we're doing is we're going to take the emotive headset, and we've been playing around with the control panel, the brain activity map, as well as the EEG. And so far we discovered some pretty cool things. For example, we once trained the cube.
Or several times. Train the cube to music.
We trained the cube when we were listening to music, and what we found was even after we turn off the music, sometimes the cube still spins. And if we turn back on the music, it spins even more. So that's one thing we found. Another thing is on the 3D brain activity map, it's sensitive enough to pick up changes in your occipital lobes, which controls your vision. So for example, we can tell when Duncan puts on his glasses or takes them off, because that region of his brain goes red. What else have we done? We're doing a research project right now where we wear the emotive headsets to class, and we're simultaneously recording the class. So what we'll be able to do is we'll be able to monitor our concentration levels of our classes, and we can see where we were maybe bored or where we maybe super concentrated, and we can rewind back the camera and we can try and find out what was going on during that time. For example, was the teacher giving a lecture? Were we taking a test? Were we participating in a class discussion? Was the teacher showing us a movie? So we're hoping to find out how individually we learn best. And we're also going to try and study the effects of caffeine on concentration. And we'll go 1 week with lots of coffee and another week with no coffee. And we'll compare our concentration levels, and we want to do the same with sleep. Is it better to stay up late to study, or is it better to go to bed and wake up early to study? And we're trying to use the emotive headsets to do a concentration study, and we'll be evaluating our teachers, but they don't know that yet.
Don't tell them.
Yeah, but we're going to do this study. We're going to produce podcast diaries that will be streamed and archived, and that's how we're going to store all of our research. Anything you want to add? Okay, thank you so much for listening.